This video is to demonstrate the importance of the cleanliness of glass prior to adhering anything to its surface. This is an ordinary piece of toughened vehicle safety glass, roughly 4 millimeters in thickness. Just to demonstrate the surface energy in the piece of glass. This glass has been around for a while, it's been in the sun, it's been weathered a bit. So as it is, I will demonstrate what the surface energy is in the glass at the moment. We'll take a little bit of distilled water and we'll put some drops of water on the glass. As can be seen, this piece of glass has fairly good surface energy, as the droplets are fairly flat and tend to stick down onto the surface of the glass. So this is a good sign that indicates that there is no existing contamination on the glass that could affect the surface energy. However, we will be cleaning it now using some isopropyl alcohol mixed with water, some ISA solution. This is a standard cleaning solution used when working with adhesives. Just to dry the glass. This is the isopropyl alcohol, 30% water, hydrated for 24 hours. This then removes all oily components on the glass, residual, and any water soluble components. It also flash dries. That seems to be fairly clean. Just give it a moment to dry. And we'll repeat our water droplet test. As can be seen, the water droplets, as they land, they almost completely flatten out on the surface of the glass. This is a sign of the glass surface being suitable to take adhesives. Okay. What I will demonstrate now is what happens and the impact that exists when there is a contamination on the glass, such as brightening agents, lubricants, silicone components, water dispersants, etc. I will demonstrate the difference between this side of the glass and this side of the glass. I will treat this section of the glass using a standard off-the-shelf windshield water dispersing agent, just for the purpose of demonstrating the significance that surface energy has. This component is basically made out of isopropyl alcohol with a little bit of sulfuric acid and then molecularized or nanoparticle silicon suspended in the liquid. It's a clear liquid, only a little is needed. It's then applied to the glass. So it's left to flash dry like that. This example of a contaminant on the glass is an extreme one, but one that may well be encountered in the fitting process of a safety punch device. If I can just polish this up like so. It's, as you can see, it looks pretty much the same as the untreated part of the glass. However, when water is now dropped on it, compared to the other side, it becomes really obvious how a little bit of contamination can truly affect the properties that's necessary for a solid adhesive bond, where in this example there is a low surface energy, and in that example there is a high surface energy in the glass. Hence the water can pull the meniscus and the surface tension of distilled water flat, whereas here the energy is not sufficient to do so, and the water droplet seems to want to form a little round bubble. What I would like to demonstrate next is what actually happens when you try to use an adhesive on these two surfaces. The one being suitable for adhesive, properly treated and appropriately cleaned, with no contaminants that affect the surface energy of the glass. The other side has let's call it a contaminant on the glass. You can see it really wipes off very clean. It makes the glass that nothing wants to stick to it. For this purpose, we will be using two identical safety punch devices from the same batch number, and they have identical adhesive on them. So with these, let me peel off the backing. We will take the device, place it roughly in the middle, and press it down for 20 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we will repeat the same exercise on the opposite side, which is contaminated. Place it in the middle of the glass. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Although the adhesive has not been afforded sufficient time, which is usually 72 hours, to appropriately wet out and to form a solid secure bond, the exercise now will demonstrate the difference in bond over even such a short period. And the other one, I think for practical purposes that demonstrates the importance of testing the surface before applying any form of adhesive to it, and something quite invisible and very slight on the glass will have a tremendous impact with regards to the performance of the adhesive.